Hi, this is Stephen Brower from Irvine Community College. This is meant to accompany Irvine Chapter 10. One of the demos that the author has in the chapter is the Drunkards walk. And this is actually a sort of a classic computer science program. And it's used for more than one reason, but one of the things that it does, it's used for keeping track of a path that something will take. The other reason why this is being done here in Chapter 10 is it actually has a structure inside of a structure. So if you had a better teacher, one of the things I would have explained that inside the Irvine 32 Inc., the author already has established a structure for us called coord for coordinates. There's other structures, also the system date time, that's used for dealing with the operating system. This structure here, this Drunkard walk, is being written on the time, and what it has is really a collection of coordinates. The premise behind the Drunkard's walk, it starts off in the middle of the screen, and then it randomly will go north, south, east, or west, and after it takes that step, it'll randomly go north, south, east, or west, and then it'll take the step, it'll go randomly north, south, east, or west. And what this program does is keeps track of all those positions it randomly went into. The thing I added to this program, to the demo that the author had, I added a visual component. So I showed the drunk walking around. Well, you'll see it in a second. And then the other thing I did is I showed the walk again. Well, shut up, Brower. Let's just do this. Okay, so the idea is it started off in the middle of the screen, and every single step it's just randomly going one step in a direction. And by the way, I didn't put error checking in this, so it could actually walk off the edge of the screen. And the other thing I did, I added these letters just so we can see the progression and we kind of know when it's getting near the end. Okay, so this would be the list of the coordinates for all these little dots here that the drunk took. What I'm going to do is I want to capture the list of coordinates on the shape so we can go back and compare it. Whoops. So we can go back and compare it. Sorry. It's doing the next piece right now. And what it's doing is it's reenacting the walk that it took. And so all those coordinates, it's reapplying those same coordinates for doing the walk on the screen, so it's the exact same walk. The idea is that once we captured that history, which was random, once we captured that history, we can go and then recreate what happened. Now, I'm not going to do this well in terms of trying to get, here we go. First, if we just look at the coordinate numbers, 4012, 3912, so the numbers that are coming back are the same ones that were there previous. And if I can do this right, look at the image, the shape that was done. So it's this walk. Remember, this one right here, I did a snapshot of the first walk, and this was, it recreated the walk that it took. And so for any doubting Thomases, let me just go and run it again. Because it's random, we should get a different shape than we did previously. And if I can do this right, the shape we got previously for the prior run looked like this. And we'll see when this is finally done what the shape of it looks like, but it should be different because it is random. So again, what the structure has is a series of coordinates. Okay, sorry, the shapes are different. What the structure has is a series of coordinates, and so that's one thing that the program is demonstrating, is to have a structure inside of a structure. I lost my place.